Hello everyone, this is Yang Zhao. For data engineering and mining final project, my topic is machine learning implementation in stock market. Machine learning, deep learning, and artificial intelligence have challenged different fields for many years, especially recently with the emergence of large language model applications such as ChatGPT. And here are some notable applications in financial area. Risk assessment. AI models can assess risk by analyzing historical data, market trends, and other relative factors. They help financial institutions make informed decisions regarding credit worth, investment opportunities, and insurance underwriting. Pattern identification. Machine learning methods use mathematical and statistical methods to identify patterns in data. Manually finding patterns in data is incredibly time-consuming and is fraught with human error, if the patterns can be found at all. Algorithms such as classification or clustering can easily find patterns to separate different classes. One of the major benefits of these approaches is that they are able to classify data that they haven't previously seen. Flagging fraud. The traditional way of handling fraud is to use a rule-based approach. In this approach, a team of data engineers manually creates rules that can segment fraudulent and non-fraudulent transactions. However, manually creating rules that cover all fraud scenarios is impossible, and as your data grows, maintaining a comprehensive rule set becomes resource exhaustive and complex. More modern approaches to fraud detection are handled using both classification and clustering algorithms. Companies want to identify fraudulent use in real time, enabling them to prevent fraud before it occurs. Why I choose this topic is because I read some news saying that AI picking stocks can beat the market nowadays. And in the middle of last month, Autopilot, which is an investment app that lets you automate your portfolio by copying famous traders in real time, launched the fund called GPT Portfolio. They gave it 50,000 to manage and are sharing the results and details on Twitter. I'm wondering how the AI choose which stock to buy. And at last, I'm focusing on the fundamental one, which is to do stock price presentation. We have learned a lot of algorithms that can be used for prediction. The simplest one is linear regression. So first, we are trying to use linear regression and decision tree regression to predict the stock price. The stock we choose is the most popular one recently, NVIDIA. The time period is from 2018 June to 2023 June, 5-year data historical price. Here is the plot of the close price. We will use 25% data and testing and 70% as training. After preparing the training data, we train two models respectively. The result of linear regression seems to be perfect. Unfortunately, this is the result of overfitting. The model should not predict the price occurred at the end of last month. It's driven by NVIDIA's strong earnings. Our model are purely based on historic price, so should not happen. And I'm not saying it cannot go up. It can go, but should not perfectly fit. The result of the decision tree regression goes to the opposite. It follows the trend at first time, then meets the pike and dives at the end of last month. Thus, the simple models make a lot of mistakes for stock price predictions. And next, we are going to use the XGBoost regression. XGBoost stands for Extreme Gradient Boosting, and it is an implementation of gradient boost tree algorithm. The XGBoost is a popular supervised machine learning model. We'll introduce some technical indicators for better prediction. First are some moving averages, simple moving averages and exponential moving averages with different rolling windows. Next is RIS. RIS indicator to predict whether a stock is overbought or oversold. The moving average convergence divergence model, which is used to detect trends and reversals. This time we divide the data into three parts: 15% for testing, 15% for validation, and 70% for training. After preparing these subdata sites, we now use a classifier to choose the best parameters. We can set a list of parameters, then the classifier will help us to find the optimal ones. We use the best parameter classifier to train our data. And here is a feature importance diagram demonstrating how much each feature contributes to the process. We can see that the 9-day exponential moving averages leads and contributes the most. And this is the result, and the one below shows only the comparison part between the true price and the predicted price. The prediction performs well all the time except the last May, in which we have discussed the reason previously. Among the deep learning algorithm, the most suitable one for our project will be long short-term memory networks. The stock price data is time series data, and LSTM is a variety of RNN that is capable of learning long-term dependencies, especially in sequence prediction problems. This time the training data is from 2018 June to 2023 April, and we make the last month's data for testing. First, we use a min-max scatter to normalize our training data, then prepare the training and initialize the RNN regressor. We add layers one by one and also the output layer. Then compile the model using Adam optimizer and mean square error loss function. For the testing set, 1 month data we have 23 entries. After the data processing, we can use the regressor to predict the stock price. The result seems to be better compared with the previous models. It follows a trend all the time with some days lagging. But I have to say, if we make the test data set larger, like 3 months data, the result will get worse. I think this is always a problem of deep learning models. They are too parameter and data sensitive. You always need to adjust them in order to have a good result. GPT Portfolio is now the first popular AI-powered fund. An ETF called AIEQ, which starts from October 2017, is an AI-powered ETF that utilizes IBM Watson to equal a team of 1,000 research analysts, traders, and quants working around the clock. It analyzes millions of data points across news, social media, industry, and analyst reports, financial statements over 6,000 US companies, technical macro market data, and more. And let's have a comparison between AIEQ and the benchmark, the S&P 500, which is tracked by ETF VOO. As an actively managed ETF, the lower price and AUM should be an advantage for AIEQ. However, AIEQ is underperforming all the time, except the most recent 1 month. The market beats the AI completely. And how about the performance of the GPT portfolio? From the weekend update, it still lagged the S&P 500. DLTR is a Dollar Tree store. The stock price dived last week mainly because of weaker than expected earning, even though they have raised their product price from 1 to 1.25. And GPT got 1.9% up, and S&P 500 got 3.5% up since May 15. So I think unlike AIEQ, GPT portfolio must not analyze the financial statements. It picked Dollar Tree and missed Nvidia. And the good news is that they announced that from next week they will upgrade prompt from GPT 3.5 to GPT 4. I think it may have a better performance from next week. In conclusion, results on investment in financial products reflect people's expectations of the future valuation of stocks, futures, and other financial products. Apart from the underlying fundamentals, there are numerous price fluctuations caused by short-term speculative activities. Unpredictable factors such as malicious news, large short position management turmoil, institutional investments, and corporate accreditations often contribute to these fluctuations. It is challenging for machines to understand human expectations based on real-time signals, especially the expectations of a specific group of individuals. The logic can always determine the directions, but quantifying exposure is typically difficult. And that's all. Thank you.